Hello, welcome back to Intro to Cognitive Science. So, today we're going to talk about deep structures of language, also in some circles known as Chomsky's linguistics. So far, we've been talking a lot about the road to sort of the cognitive revolution, as it's often called. We began with the behaviorist movement and how it started turning the study of psychology towards a more rigorous, empirical, scientifically minded approach. But we also looked at some examples of roadblocks that prevent the theories of the behaviorist movement from explaining everything that's observable, right? So one big one being language, which we'll spend a lot of time on today. So we also talked about the concept of information processing, how Turing revolutionized the field and actually created the field of computation, and the idea that we can make systems that physically real systems, actual physical systems, that are capable of moving information around in predictable ways. And these two ideas kind of come to roost together here today because we're going to talk about language, something that our physical brains are quite capable of maneuvering around and wielding really well. Really well. It's one of the grand, almost mysteries, but one of the most amazing things the brain can do, honestly. So, let's dig in. The world is full of languages, right? We all have a great deal of experience with English, I believe. Maybe not every one of us. There might be some second language English speakers here, but we also know of all the other languages that we encounter in our daily lives, right? And in every case, we are using these symbols to communicate ideas to each other. The different languages have different rules, but at their heart, all of the sounds are arbitrary. The word sounds and the word arbitrary, those are just those are just sounds coming out of my mouth, hitting your ears. The idea here is that those are symbols. They signify something. The letters signify the sounds, at least in written English. Some languages don't use written language that way. But in general, the idea is we have assigned meaning to all these things, and we wield them just so well. It's great. It's amazing to see. The fact that I am spitting words into a microphone that's getting recorded onto a system that will then later hit your ears through some kind of reverberation out of a magnet is pretty great. So, there's a lot of different varieties to our languages, right? But they all are achieving the same basic idea. But even within a language, we have some different rules sometimes. Even if you break English down, there's a huge difference between American English and British English. Some of the ways that we refer to things, at least so the semantics of certain words don't make sense across language. Maybe that don't make sense, but we say elevator over here in America, and they would say lift. Both make a kind of sense, but they're just a slight difference in how we use it. We even get down to some different syntax and things, right? So even within a language, there's a huge variety out there. But the question is, how are we actually solving all of this? Because it doesn't really matter what these surface level rules are. There's got to be something that we all have in common that lets us convert arbitrary sounds and symbols into some kind of meaning. And that's where Chomsky comes in. Meet Chomsky, one of the fathers of linguistics, modern linguistics, of course. he pushes this idea further. So languages have typically up until this era, the study of language is focused on kind of pulling apart surface level features of different languages and studying, ooh, how are they all different? How are they all interestingly different from one another? Chomsky comes in and says that's chaff. That's all sort of immaterial to this bigger, deeper question of what the heck are we able to, why is our brain able to do this, and it's able to do it so well across all cultures, right? Like we all tend to use language in a very similar way, even if the rules are a little different, even if the specific syntax of Mandarin isn't the same as Japanese, they are both language. So Chomsky's concepts of this deep structure, deep syntactic structure, helps us analyze all of language and helps to give an explanation of why languages work in the first place and how language is sort of rooted in this very information processing based approach. So how we manipulate this hierarchically organized information to make meaning and move it around. So let's look some more. Two big things. There's a separation between syntax and semantics. Syntax is like the rules for what you're allowed to write and have it be a properly constructed sentence, right? So these are the rules of how information must be laid out. Whereas semantics are the meaning of the individual words, sort of the content. What does the word mean? What does the word cat mean, right? We know what these words are getting at because we understand their semantics. So semantics have a clear amount of interest, right? How the heck do we even do that? There's some mysteries to be solved there. But Chomsky wanted to focus on sort of what some might think of as the more boring side, which is, I disagree wholeheartedly. But syntax, this is the idea of what are the rules, how do we actually access our ability to understand the rules of syntax. And I can demonstrate this here. Let's look at this sentence. The lazy cat recently had a... Ooh, that's gotta be a little bit annoying to read, right? Why is it a little annoying to read? Because the words are fine, they all have semantic meaning, but the syntax is broken. This sentence violates the rules of syntax. The lazy cat recently had a what? What did it have? Maybe a good nap, I hope. But there's a blank. Your brain is expecting something, and it doesn't receive it. That is demonstration that the rules of the syntax, you comprehend them. Now, in the opposite case, this is Chomsky's favorite version of things, or demonstration of this the opposite phenomenon. Colorless green dreams sleep furiously. Okay, so think about this one. This actually is a well-structured sentence. It has all the parts, right? Its descriptors all match to nouns. There is a verb. There is content here, right? It is describing something, but it's describing nothing. There is no semantic meaning to this stuff. Colorless green is already a problem. Dreams that sleep, don't understand that. Sleeping furiously, oh, well, that's even more wild. This is a sentence that is well constructed. We comprehend its syntax, but it has no discernible meaning. It could mean whatever you want, right? It can be a Rorschach test, but it's not tied well to actual semantic meaning. So now I'm gonna take an aside and let Chomsky go over some of his own thoughts in this nice little interview video. myself, and here we go.
There are a good many people, specialists in the field, as you know, who believe that language is simply a matter of training, that a child can be trained to speak, and that there's nothing unique about this. You, I know, feel that there's something more than simply training. Why do you feel that there's something more to learning language than simply training?
Well, first of all, it's worth mentioning that most overwhelmingly people learn language without training. I mean, if you simply immerse a child in a situation in which language is spoken, he acquires the system.
But it's more than a response to the stimuli of the person around him speaking?
Well, the most obvious and sort of gross fact about language, which shows that, I think, is the innovative, creative character of it. I mean, every child is capable of understanding and producing very complex structures which have no simple relationship, no point-by-point relationship, no relationship on the basis of analogy, let's say, to the experience that he's presented.
The generative, creative structures of language.
Just that you can, as we're talking, we say new things, which we may not have said before. We hear new things.
I mean, language is, well, as we talk, there's very little repetition in what we say?
Well, if you really were to see how little repetition there is, you can, let's say, take a book or a newspaper or a library, for that matter, and search for repetitions of phrases or sentences and so on. They occur, but rarely so. I mean, there are particular subparts of language, say greetings or conventional utterances of one sort or another, that do repeat frequently, but these are incidentally often marginal in their structure. For example, a sentence like "How do you do?" has a structure which is, in fact, unique. It's not the structure of any English sentence. And we don't create new sentences of that type. That's just a ritualized utterance.
Yeah.
But most of our linguistic interchange is, in fact, highly innovative. And of course, it's not just random. I mean, it's innovative, but somehow appropriate to situations.
It doesn't necessarily follow the rules that we were all taught in school of a subject and a predicate or a noun and a verb. I mean, I would have the impression that somehow in my schooling I was taught to do what it is that I do now.
Yeah, well, people have that impression, but the reason is that the actual rules of language, which certainly are not taught in school, because in fact nobody even knows them to this day, are totally unconscious. I mean, what you're taught in school is some relatively superficial set of generalizations about some of the products.
Are they important? Is it important to know that?
Well, I think it'd be important to know it, but the point that has to be stressed is that first of all, that everyone knows, speaks a language very fluently and a very rich language before he ever goes to school. And furthermore, even if you wanted to teach somebody the rules of language, you wouldn't be able to do it because the rules are largely unknown. We're just barely beginning to discover them. It seems to us that there's no problem in speaking, just as it seems to us that there's no problem in, let's say, walking. But if we were to try to design an automaton, let's say, that would walk or ride a bicycle or identify a person. I mean, for example, you look at me from one point of view, and if I turned my face, you could still recognize me.
Yeah.
That's not so easy to do. I mean, we can do it because we have some special unknown capacities for perceptual identification. Well, in the case of language, too, we have this whole totally unconscious set of intricate mechanisms.
I mean, something's built into the system?
Well, I have no doubt that most of the richness of the structure of language is just the biological property of the organism. Can't be taught any more than you can be taught to have two arms and two legs.
You've got no way that you can X-ray it or put your finger on it.
At the moment, neurophysiology is not in a state where one can detect the physical structures that underlie linguistic use. I mean, only rather gross things are known. For example, it's known that language is controlled by the dominant. The brain has two hemispheres, and language is controlled by one dominant hemisphere. Incidentally, humans are, as far as I know, as far as anyone knows, the only organism that has lateralization, that has specialization of the two hemispheres. Apes don't, for example. And this is, as is well known, this is closely connected with language, and areas of the brain are known that have special relevance to various language functions. But when you get into the detailed, intricate structure of the system, it's still a mystery, entire mystery. One might say the same about learning. Nobody knows anything about the neurology of learning either, for that matter.
Now, one of the most controversial things that you've come up with is the fact that what you're saying is true not only of English, but true of all languages. There's a commonality that runs through all languages. I would have guessed that some languages were so rigidly structured that if you learned a set of 20 rules, it would take care of all situations.
Well, see, if what I just said before is true, that is, if a great deal of the structure of language is just a biological property that you bring to the learning situation, not something that you acquire in it. And if we further assume, as is unquestionably the case, that humans are not specifically adapted to learn one language or another, that is, there's no racial difference that makes it easier for you to learn this language or that language or something of that sort. From those two assumptions alone, it follows that all languages are going to be essentially uniform in that part of their structure which is biologically determined, just as there are only going to be certain possible limitations in the kind of gait that you can use when you walk. And you can't fly, no human being's going to fly. We're all going to walk. We may walk in slightly different ways, and these may be culturally determined in part and so on. Well, I don't want to press the analogy too far. There's more differentiation in language than that. But still, I think that there is simply a biologically determined, rich framework, which we can learn a lot about, incidentally. I think we can find out a good deal about it, and there are interesting theories about it that predispose us to acquire a system of great complexity of a very specific sort on the basis of a very slight familiarity, a very slight exposure to data. See, one of the most remarkable things about acquisition of language is that the child, or for that matter an adult, has had very few seconds in his lifetime, and the total range of data available to him is rather small as compared with his ability to express himself and to produce and understand sentences and utterances and discourses as he does in his normal life. And that again indicates that there's a rich biologically determined structure, which therefore must be uniform across languages. Now, as far to get back to your original point, whether there are languages with a small number of rules that would suffice to explain everything, certainly nothing of that sort is known. I mean, insofar as languages have been carefully studied, living languages at least, they seem basically they do differ. I mean, one language is not another language, but they don't differ as far as we know.
There still is this creative aspect in all languages.
Well,
that is generative.
That's absolutely universal. That's just a human property. I mean, which is true of every language.
So, good to hear. It's nice to hear these old-style interviews are very, very in-depth and engaging. His approach here is getting at the idea that, as I mentioned before, there is a deep structure that is closer to biology than it is to something that is basically learned. And the question is, how do the mechanisms of that structure work? So, let's look a little bit more in depth at Chomsky's approach here to understanding the deep structure of sentences. So, deep sentence structure, or sometimes known as the phrase structure of language. There are two things: components of the sentences and the rules for those sentences. So components would be things like syntactic categories. When you think about a sentence, we know certain things like there are nouns, person, place, thing, objects, right? There are verbs, actions that you take. There are adjectives that describe nouns. There are adverbs that describe adjectives or verbs, right? There are lots of pieces of language that we're using. You're using them right now. You're processing everything I say in terms of the nouns, verbs, adjectives, and subphrases involved. And you're not even really thinking about it, are you? See, that's why this is so powerful. You're just able to do this. That's kind of wild. So the components are the sort of the atomic pieces of the sentence. And then there are the rules. So grammatical rules, these context-free grammars, these are what allow us to parse out a sentence. If I just threw a jumble of nouns, verbs, adjectives, and subphrases and all that kind of stuff at you, you might be able to make some kind of sense of it, but the rules of syntax, these context-free grammars, are what help us keep track, right? So, for instance, a sentence, S, could be made up of a pair of things, a noun phrase and a verb phrase. A noun phrase, in turn, might be broken out into a determiner, like the, or a, or an, and a noun, cat, right? Whereas a verb phrase might contain a verb and an adverb. And so on. So an important idea here is that these are nested structures. So let's look at a toy grammar. Here are the components: nouns, people, places, things, pronouns, verbs, actions, determiners, the, a, an. Noun phrase, a subphrase that contains a noun, verb phrase, a subphrase that contains a verb, so on. Now the rules. A sentence can be composed of a noun phrase and a verb phrase. A noun phrase could just be a noun, or it could be a determiner and a noun. Whereas a verb phrase could be a verb alone, or a verb phrase could be a verb and another noun phrase. Aha. So let's look at a couple of these. He is a jerk. Okay. How could we parse this out? Well, we always start from the root, which is this is a sentence, so it's got to be broken up into a noun phrase and a verb phrase. Okay, cool. He and is and a and jerk. How do we make sense of this? Well, he is a noun. It's a person. It's a pronoun, but it is a noun. It doesn't have a determiner on it, so this noun phrase just becomes a noun. Okay, he, great. Verb phrase. Now we have to make sense of the rest of the sentence. Is, well, that's a verb. A jerk. Oh, that seems familiar. So this looks like it's going to need to be broken up into a verb and another noun phrase. Is. Okay. Now we have a jerk. Aha. Determiner a and a noun. Ta-da. This is syntactically correct. This is solvable. It is parsable from the rules that we've determined in this little toy grammar. We can create this sentence. This sentence does not trigger our error signals in our brains, right? But let's look at the two we'd looked at before. So the lazy cat recently had a. We won't dwell on the rules of this particular toy grammar, just follow along. So we start with a sentence, breaks up into a noun phrase and verb phrase as before. This one will include an adjective phrase because we have lazy is involved, right? And, oh, well, we have space for a noun. Okay, so determiner and adjective and noun. Great. Then we had recently, so adverb and a verb phrase. Okay, verb phrases. Cool. Let's break that out. So the verb is had. Cool, cool, cool. But then there's something that comes after had. Had a. Is a determiner. So that's probably going to be part of a noun phrase. But there's never a noun phrase without a noun. This is what's missing from this sentence. We've broken everything else down quite cleanly into these recursive rules of grammar. And we see where the syntax fails. There is no valid construction of the rules of this grammar. Again, it's a toy grammar. Don't harangue me, linguists. I know it'll drive you nuts. But then there's a space here that requires a noun, and it found none. That's your brain. This is why your brain reading The Lazy Cat Recently Had a says, where is it? Where's the last piece? Whereas colorless green dreams sleep furiously is perfectly happy. Sentence, noun phrase, adjective phrase. Okay, colorless green dreams sleep furiously. Solved. Okay. So the powerful idea here is that whatever the specific rules of your particular language, what order the noun phrases and verb phrases come in, whatever, your brain, we're all doing something at the base level that is just moving this information around. So your brain can still tell without you understanding exactly how, even, right? When I first said the sentence, The Lazy Cat Recently Had a, you probably weren't thinking about how to diagram that out, but something in your mind was doing it anyway, or doing something like it. I don't want to make it seem as though this is totally solved, as if we've located the structures. We still haven't located all of the structures of language, but the idea here is that we're still doing it, and we do it quickly and powerfully. So you're using some kind of internal rules. You are maneuvering this information within your brain. It's not just a reaction chain. You can tell internally. It doesn't require some kind of stimulus-response pairing for you to understand that a snippet of text is syntactically invalid. And it also shows, more broadly, like we've talked about since the behaviorism content, is that this is showing off some hierarchical structure. We are able to do this recursive sort of nesting understanding of language. The language comes in a linear way, but then we parse it in this hierarchical way. Okay, I'm going to take a quick aside here to talk about some of these ideas. So, hierarchy. This is the idea that some structures can be nested within others. So this is very much the grammar rules, and helps to make sense of the complexity of a great many things in cognition, in the world. Although don't stick to it too closely. Hierarchy can lead some bad places. But the idea is that we can parse out the world and particularly language in these sort of categories. We can make sense of things top down. Now, further, recursion is the idea that some structures and processes can actually be nested inside themselves. This is a tricky thought. I'll show you a couple of ideas here. Fractals get at this really well. So the same process might compound on itself multiple times to produce something that looks quite complex, but really is guided by an individual single rule. You could expand, for example, in the language stuff, we could expand out noun phrases, or I suppose verb phrases, out infinitely. You don't want to do that. It makes some confusing sentences if you take it too far, but it works. So, and then the idea of emergence is that sometimes very complex structures and patterns can be the result of actually a relatively few set of simple processes, and especially recursive ones. So let's take a look at some fractals just to sketch this out. Here's a simple fractal. Here is a little hexagon, or if you're particularly imaginative, that might be just a black cube. Here's the rule. Put another hexagon at the top, bottom left, and bottom right vertices of this hexagon. Make it half the diameter. Okay. We just keep doing that and doing that. You get a very complex structure just from this very simple recursive rule. Apply it over and over and over, and you can get as finely detailed as you want. Some of you may have seen this one called the Sierpinski triangle. All you do is you put an inverted triangle within the black triangle. Just keep going and going and going. Okay, neat trick of math. Cool. Does it help to understand? Well, in some ways, you can look to biology. Biology has a lot of these kinds of fractals, these kinds of recursive repeating processes. So things like your capillaries and sometimes your neurons are shaped in a way that could be explained by one simple rule applied many times. Fork when you get to a certain amount. Fork again. Fork again. Broccoli actually does this. Broccoli forks in an almost identical pattern every time it splits, all the way until it gets to the little tiny leaves that make it look like a tree. Check next time you look. Okay, so this is the idea of and this is, again, this is an aside, right? We're still on the topic of language generally, but the aside is that these kinds of rules, these recursive patterns of structuring, getting complicated structure out of actually relatively simple and few number of guiding rules is common. And it leads to this mode of thinking that I think is really important. And that is understanding, as I brought up on a previous slide, emergence. Think about an ant walking on a beach. You may observe the ant and see that it has this really complex, winding path through the beach, right? Along the beach. If you were just thinking about this path, you might think, wow, the ant has a very rich, complicated plan. It's doing all these it's jumping through these mathematical hoops to plan its very complicated pattern along the beach. But is it? Or does it have a really small set of patterns that it follows? Walk forward until I get to an obstacle, move around it. Walk forward until I get to an obstacle, move around it. All seeking food. Walk forward, seek food, avoid obstacles. Walk forward, seek food, avoid obstacles. This is the idea of emergence. That a small set of simple rules applied broadly can sometimes give rise to very complex overall patterns. Now, I don't want you to take away that everything is all just very, very simple rules. In fact, sometimes these rules can be very intricately connected. But just the idea that very complicated things can be explained by small subsets. Okay, so back to linguistics. We are good at language. We're inclined towards it. We are almost born to it. Okay? And another key idea of looking at linguistics today is that not only do we parse it, not only do we recognize, this does or does not fit into X structure, we can also transform language pretty easily. And that's not straightforward. Look at these two sentences. John has hit the ball. The ball has been hit by John. Those are the same content, but they're constructed wildly differently. Here is John has hit the ball. Here is the ball has been hit by John. We're not going to dig into the exact structures there, but they are so different. Look at them. The order is all over the place. You would maybe call one of these passive voice and one of them active. Although I guess has hit. It's always such a slight mess. But apart from stylistic decisions made by editors, these are the same content. It communicates the same situation. A ball has been struck by John. John has struck a ball. We are able to see that these are the same situation semantically, but the semantics also are brought on, in this case, the complex semantics of like understanding the whole of what happened. We reach them from two different angles. So comparing these two structures, they're very different syntactically, but we have the same meaning, and you'd probably use them kind of interchangeably. Another example. This is actually to the opposite case. Susan is eager to please. Susan is easy to please. Now these are almost identical syntax. Look, the only thing that's changed is one of the component, one of the adjectives. But they have completely different meanings. So this is more of a semantic side of things, but back to John has hit the ball has been hit by John. How do we explain this? These are almost exactly the same content, but they have structures that are so totally different. And we don't even stutter when we imagine the differences between them. So the idea here is that not only do we have rules of grammar that help us parse for syntax, we also have rules that allow us to transform one syntax into another. So the active to passive phrasing rule, active phrasing would have noun phrase plus an auxiliary phrase plus verb and noun, whereas passive is noun auxiliary bin verb by noun. These are the rules. This is a way we can take one structure and then turn it around, reorganize it, chop it up, and be able to not only make sense of it, but also spit it back out in a different structure. If I said, tell me what happened, you might pick one or two or the other of those sentences at random. Not sure. It might be down to your particular style of speech, right? But you are able to take in the information in one form and just chop it up and move it around according to these other extra rules here. So, not only do we have these structures to make sense of language, we can also apply algorithms to those structures to move that information around and apply different rules to couch our knowledge, to capture the knowledge from the sentence and be able to reconstruct it in different ways. So, overall, language is this really cool thing, this sophisticated, hierarchically organized ability that we have. And because we can both produce and understand speech and language by using this stored information, whether it's biological or whether it's something that we have acquired, some of each in these cases. We rely on these phrase structures, the internal models of what is valid, and these transformation rules of how to move from one model to another. And we can do this all algorithmically. A Turing machine can do a lot of this. That's how spell check and grammar check work when you're in a text editor. Not spell check, that's different, but grammar check. Okay, so far, we've seen behaviorism falling short in a couple of categories. There's some interesting ways that the internal mind has been demonstrated in certain lab studies and in the study of linguistics here. Turing comes along a different vector and kind of unifies the theory of a physically realizable general information processor. And then Chomsky offers an explanation not just for the structure of language, but the deep common structure between all languages. Okay, I'm going to end this one with an interesting curiosity, an interesting example of sort of an edge case, I think. Would you believe me if I told you this sentence is both semantically sound and syntactically sound? Buffalo, 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 buffalo. Sounds ridiculous. But there's an explanation, and I'm going to let this little video show you.
You may think you know the words that sit plainly in black on your page. But don't be fooled. Some words are capable of taking on different guises, masquerading as nouns, verbs, and adjectives that alter their meanings entirely. This seeming superpower is called lexical ambiguity. It can turn words and sentences into mazes that mess with our minds. For example, consider the following. Buffalo, 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 buffalo. That may sound like nonsense, but it's actually a grammatically correct sentence. How? Well, buffalo is a proper noun, a noun, and a verb. It refers to an animal also known as a bison, an American city, and it can also mean to bully. These different interpretations create a sequence of words that is grammatically correct as it stands, though it helps to add in a few implied phrases and punctuation marks to reveal what's really going on. Buffalo buffalo are bison from the city of Buffalo, and this sentence has 3 groups of them. Group A, which is bullied by Group B, bullies Group C. In other words, bison from Buffalo that other bison from Buffalo bully also bully bison from Buffalo. If you let each buffalo perform its role, the meaning becomes apparent. What if the bunch of bullying buffalo decides to cross the ocean? Not just on any ship, but a ship shipping shipping ships. That sentence sounds just as outrageous, but there's logic to the babble. Ship can mean a vessel and to transport. When we sub in those meanings, a clearer picture emerges. Here we have a huge ship-carrying vessel, transporting ships that themselves are designed to carry goods across the sea. A ship shipping shipping ships. How about some entertainment on board this unusual vessel to offset the scuffling buffalo? Consider the can-can. Can. Here, the word can comes in many guises. There's can-can, the flamboyant dance, can that means able to, and can figuratively meaning to outperform. By sticking in a comma and including the implied meanings, this sentence becomes clearer. Can-can dances that can-can dances are able to outperform can also outperform other can-can dances. You wouldn't necessarily use any of these sentences in a conversation. They're just too ridiculous. Yet they serve as an extreme example of just how tangled everyday language can be. Lexical ambiguities sail into our speech and writing all the time, spreading confusion and misunderstanding wherever they can.
So, to recap, this is perfectly syntactical, and it's semantically meaningful. It's just still a hot mess. All right. Now, final thought. What are other ways we use hierarchical thinking to make sense of the world? All right. Thanks. Take care.